Hello everyone, and welcome to this video. I'm going to try to demonstrate how to set up and configure a EVPN VPWS service, or also called EVPN E-line, or just simply point-to-point service. On the left side, I have two dual-homed PE routers, and on the right side, I have a single-homed PE3 routers. I'm using, by the way, OcNOS from IP Infusion as network operating system and using GNS3 as emulation tool. So first thing I would like to show you is simply the IP addressing quickly on PE1. So here you see that I have um, loopback IP address. It's 10.10.100.1 for P1, .4 and .3 for P3, and .2 for P1 here. I'm configuring label switching under each interface within the MPLS core. Here I'm using segment routing, MPLS forwarding the transport plane. These interface are under ISIS IGP process, which is configured with segment routing MPLS enabled. So all the prefix SID, adjacent SIDs are being advertised through ISIS. Here explicitly, I configure prefix SID for loopback IP on each of these routers. So it will be 101 on PE1, 104 on PE4, and 103 on PE3. I can quickly have confirm that ISIS is discovering the topology. So I have all the nodes within my IS topology. I can have a look on MPLS forwarding table, and I see in order to reach PE3 loopback address, I need to use the out label 16103. I can quickly make a MPLS trace route using with destination the loopback IP of PE3. And I can see clearly that the first hop is using label 16103. So once this prerequisite is done, the next step would be to check, to have a look on the configuration related to the EVPN service by itself. Of course, first thing is to set the BGP. So here I have a BGP that was my route reflector is .2, which is PE1, that is reflecting all the routes. And I'm activating layer 2 EVPN, layer 2 VPN EVPN for it. So quickly at P1, I can, if I run the command show neighbor summary here, I see I have 1, 3, 4 that are 3 neighbors that are established for this specific address family. Now, next step after after confirming that BGP is working is to configure the three things, if you like, or three main points. Is the service itself. Service itself is made of a port channel interface that groups Ethernet 7 and Ethernet 2, because this is a dual homed configuration. So port channel, and then port channel sub interface that defines the VLAN, the Ethernet VLAN frames, a tagged frame that I would like to transport over this virtual wired service. One, then map this to a VPN ID, and this VPN ID then is mapped to a MAC VRF. To simplify the concept explanation, I made just a slide here where you can see the parallel between the configuration and the concept. So you see here from the left side of the screen, I have the port channel subinterface PO1.31 that defines VLAN 300 to select the frames to be tunneled. Okay, so this is reflected here. Port channel by itself, PO1, is configured as multi-homed segment with the system MAC that is crucial to be set, and should be to be in order to generate the ESI that is unique within the network. Okay, and you see here under Ethernet 7, Ethernet 7 is a member of this port channel 1. Okay. Now, and by the way, here I'm setting a all active port channel. So both links of the Ethernet segment are active at the same time. Next step is to attach this port channel subinterface to a virtual network identifier or VXLAN network identifier in the OcNOS terminology, which is a VPN ID, which is a local ID to PE1, and this is done here. Okay, sorry, no, it's done here under PO1 301. This is where I map to VPN ID 301. So meaning I'm creating that link between the port channel subinterface and VNI 301. Now, this ID is created by itself with this line command. It maps the local ID to a remote ID. The remote ID is configured locally on PE3 as you see here. So PE3 has the same configuration but in the opposite side. It has a local ID of 302 and a remote ID of 301. And then I map this VPN ID to P2P-SH, which is the name of my MAC VRF, which is represented here by the blue square. All right, and this is where I define route distinguisher and route target. In fact, basically what PE1 will do is that it will send BGP update message containing Ethernet auto discovery route to in fact to advertise the MPLS label that should be used by PE3 in order to forward frame within or to VNI 301. Okay, so imagine you have a BGP update message from PE1 saying, "Listen to PE3. Listen, if you want to bring me Ethernet frame that are tagged with Ethernet 300, and I need to forward locally to my sub interface here, they have to be tagged with that specific label, and vice versa." This is what PE3 will say to PE1. So now another advertisement is important, which is Ethernet auto discovery route per ESI. So PE1 will also advertise the Ethernet segment. Okay, so this is for the PE3 to understand that the PE1 is a dual homed. Okay, so it can forward and load balance traffic to PE1 and PE2. And here we can have a look if we can show EVPN multi-homing. So here I see clearly that on PE3, the Ethernet segment ID, so this is a system MAC here, I've configured on PE1. So to reach that segment, I can do it with via these two peers. Okay, this is done. This is being generated based on this route per ESI, auto discovery route per ESI. If I also furthermore check layer 2 EVPN updates, scroll down. So here you have the routes. In fact, you see here you have a nice explanation saying the route is the route type, ESI, VNI ID, and relevant information, which is basically the label. So you see I receive, for instance, here from next hop from .1, so from PE1, I'm receiving route type 1 for that Ethernet segment, for that VNI or VPN ID, and that label. So meaning I should use that label in order to forward VLAN 300 traffic to PE1. All right. And if I go now to the .4, for instance, this one, if I look here, okay, yeah, this one. So you see here with this route, Next hop is .4. So this is the PE4 that is advertising. Same Ethernet segment, same VNI, but now it's labeled 17. So it's labeled 17 that I should be used to reach PE4. I can confirm that by issuing this command, show EVPN MPLS X connect. So I see here in order to reach that segment, I need to go through these two peer, but I need to go through more information than this. So I do tunnel and label. And then here I see that you see the remote label that I should use to forward traffic to VNI 301. Okay, is these remote labels 17 for PE4 that is advertised by PE4 and 25601 that is advertised by dot one. Okay, quickly, if I do a capture, a Wireshark capture here, I can have a look on the BGP update message. I'm already on it anyway. So you can see here, you see this is the BGP update message, pass attribute multi-protocol reach, network layer reachability information. Next hop is .1. So this is advertised by PE1. This is a Ethernet auto discovery route type 1. This is the ESI, and this is the VNI. So the VPN ID, which is 301, and that is the associated label that you just saw. So again, PE1 is saying, in order to forward relevant Ethernet frame within that service, you have to use that VPN label, which is 25601. Yeah, that's it. Hope this was informative to you, and stay tuned for other upcoming video. Thank you.